Hello, everyone. Thank you for joining our very first edition of Simplifi Tech Talks. My name is Ambrose Ahura. I'll be taking you through this session. First of all, we are delighted to introduce Simplifi Tech Talks. This is an initiative that we've created to help us share ideas about technology, about network and communications with our customers and the tech community at large. And ultimately, we hope that through this kind of initiative, we can be able to create more value in the solutions that we come up with, network solutions, and also be able to exploit technology, use more and use better technology to carry out some of the designs and implementations that we are doing. Today's session is in partnership with ICT Association of Uganda. So a big thank you to the folks at ICTAU. Just a brief about myself. I am currently with Simplifi Networks as a support engineer, where I handle most technical queries regarding some of the products we carry, be it MikroTik, Big Ubiquity, and mostly fiber as well, Ep1, GPON, and that kind of stuff. Today's session is about fiber optic, and just to give you a bit of background on why we chose this particular topic, through our various interactions with customers and with different stakeholders, we've noticed that there are so many opportunities where we could adopt the use of fiber optic in our installations, in our designs. Some examples where someone is trying to install a camera and he has cable runs that exceed 100 meters, and they are stuck with maybe repeating Ethernet and that kind of design. You could easily swap out fiber optic. We are also seeing a lot of use cases for fiber where people have been struggling with microwave point-to-point or point-to-multipoint, and there's a lot of interference. We are seeing that there isn't as much adoption for fiber optic as there should be to kind of mitigate the struggles that arise from a lot of interference. There is also looking at introducing fiber in areas where folks have been quoting a lot of Cat7 or speccing a lot of Cat7, and the question is, if you need to go Cat7, why not have some fiber in there? Because fiber will give you 10G, it will give you 40G, 25G at much longer lengths as compared to Cat7, which may give you 10G but different lengths. So that is kind of the motivation for today's session, which incidentally we're calling Fiber All the Way. Just to kind of glance at what items we are going to touch on. We want to first of all talk about what is fiber for folks who have not installed fiber, who have not dealt with fiber to a great extent. So we just want to briefly touch on what is fiber optic anyway. Then we want to look at the different types of fiber optic cable. Maybe there is barrier, you've got aerial, you've got drop cable. We want to kind of talk about when to use which type and kind of describe a little bit in detail what each type looks like and the physical characteristics of each type. We will also look at Singlemode versus Multimode, as well as we want to demystify some issues surrounding Cat6 versus fiber optic. I know that is a question that tends to be on a lot of people's minds, and we want to state some facts. Things like which one is actually more cost effective if you're trying to do a design. We want to kind of lay the facts out for you to see. Then we will also look at how to actually set up a fiber link, a simple point-to-point fiber link. What bits and pieces do you need to actually achieve that? We'll run through all the small little pieces that you can actually source yourself, and then you can set up functioning fiber link. Then we'll look lastly at the fiber tools. We'll talk about the toolkit you must have as a fiber optic engineer if you're installing, if you're maintaining, or if you're just learning, what tools you must kind of get to grips with to be able to effectively run a fiber network, or add it to your LAN, so that you can begin to embrace fiber in your designs. So looking at what fiber is, just the easiest way you could describe fiber is just a glass tube. They're just strands of glass that typically are insulated in a casing for mechanical strength, and these are able to transmit information using light pulses. So light travels very fast, and the engineers exploit that fact to be able to transmit data over fiber and then achieve longer distance, high bandwidth transmission. So typically with fiber, you have distances that exceed 100 kilometers, and then you can achieve speeds or bandwidths of up to 10, 40, 100 gig, and so on, even 400 gig. So you begin to see the capabilities of fiber and why you really need to have fiber optic in your network. Just to touch on usage of fiber, we'll have some kind of fun facts that I stumbled into as I kind of researched on different facts about fiber. So you've got the whole world is surrounded by fiber, if I may say. You have a lot of undersea cables. There's a whole undersea cable network that covers our continents, as you can see there. And the longest span of undersea cable is about over 39,000 kilometers, I believe, according to a source that I got. So you can see that when you're loading your YouTube video and it's loading very fast, it's because there's a backbone of fiber optic that enables it to traverse from wherever the servers that host YouTube are to reach you, and so that you can be able to have a good experience on your browsing. Another fun fact that we actually want to share is the time it takes for you to ping or to talk to a computer. And this time we were talking to a computer in New York from different cities around the world. And typically 90% of this traffic is moving over fiber optic to be able to get to New York, which is the test city we had. And you could see Kampala, which is some good 1,000 kilometers away, but you can reach there in just a couple of 100 milliseconds. That just goes to show how it's a fiber world, how the fiber still runs our networks. So we want we've kind of seen how fiber is running the world in terms of fiber, in terms of backhaul, but now we want to promote more and more adoption of fiber optic into our local area networks, our small WISPs, our ISPs, even maybe things like FTTH, so that we can all benefit from fiber optic. Then there is also the small issue of single mode versus multimode, and we want to again talk about what is single mode fiber, what is multimode fiber. And just to describe each briefly, single mode fiber is typically fiber that you use for doing long distance, high bandwidth links. Anything beyond, if you need anything beyond a link of any length beyond 800 meters, you're typically going to use single mode fiber. And it typically uses wavelengths of 310, 1550, sometimes you have 1600, 1400 nanometers, and you have much thinner beams of light that transmit this data. In terms of physical differentiation, typically single mode fiber has yellow sheathing. Those are patch codes at the very least. You'll typically find in a yellow color with a fiber cable typically is associated with single mode. Now, when you look at multimode, this is a cable that is typically used for short haul, very short length cable runs, and you tend to get not as high bandwidth, but you can get high bandwidth as well. And typically you find it utilized in applications where the distance is not a factor. So typically you find switch-to-switch connections over fiber being multimode. You find a lot of adoption in data centers for multimode fiber. And of course, in terms of physical differentiation, you typically find that sheath colors tend to be aqua or orange for multimode fiber. Then we also have differentiation in terms of the kind of deployment that you're going to use your fiber for. So you have what we call area fiber, you have what we call barrier fiber, and as well as drop cable. And each of these has got circumstances when it's best suited, when there will be a circumstance where you want to use area fiber, or there'll be probably the environment you're trying to deploy in, or maybe you don't have right of way to dig, or you can't plant poles, things like that. So looking at aerial versus barrier fiber cable, you kind of get the intuition from the names. Aerial fiber is typically fiber you see run on poles. Typically these days on most streets you see poles that have that are supporting fiber cable alongside the poles that run the electricity lines. So you tend to find poles with spans of say 50, 100, 250 meters, and that is usually a spec within a particular make of cable, that this one can span 100 or 50 meters or 150 meters without damaging the internal cores of the fiber. So you kind of gives you an idea of how many poles you need to cover X length of X distance of a certain area. Then we also tend to see typically aerial fiber being what we call ADSS, which is a version of fiber with a non-metallic construction. And you tend to have this because typical deployments tend to be alongside electric lines. So we always want ADSS cable because there is little to no risk of electric shock in case the cables get in contact with electric lines. Then as far as barrier is concerned, this cable is you tend to have reinforcements within the cable, maybe some metallic strength members and metallic cladding in and around the cable before the plastic outer sheath to give it the mechanical strength necessary so that it can be buried without harming the cable or the small strands of fiber of glass that transmit our data. So that is barrier and area. Then we also want to briefly mention, we want an honorable mention for drop cable. Drop cable is a cable that tends to be deployed from the last or the distribution point from the ISP's network to the customer. It is a cable that is used to terminate customers. So you typically find that drop cable moves from the pole into the house so that you are able to terminate or provision customers that are receiving internet services over fiber optic. Typically, drop cable comes in core counts of 2 core, 4 core, 6 core, as opposed to the other bigger core cables, which may start from 6 core up to probably 144 or even more cores. So you typically have a construction of tubes within the sheath of the cable, and each of those tubes has got varying number of fiber cores or fiber strands, depending on how many cores a particular fiber cable is. We see a lot of use for 2 core, 4 core, 6 core in small LAN installations, small local area networks. Usually this kind of cable suffices because it is relatively lower cost. as well as in FTTH deployments. Now, of course, I remember saying we want to demystify some of the misconceptions surrounding why someone should use copper versus why someone should use fiber, and we want, with the goal of promoting the adoption of fiber optic in our networks, whatever the size, we want to kind of show that most of the time, where you can put Ethernet cable and probably Cat7, you can easily put fiber at either the same cost or much lower cost, but enjoy the benefits of fiber, which include, of course, you don't have interference, you don't have things like limitations on distance. So you can run fiber cable for 10, 20, 30, 100 kilometers without having any issues. Of course, that is not to say that fiber cable does not have issues. You typically need a little more to terminate fiber cable. It's a little more involved compared to the Ethernet. And also, repairing faults is not as straightforward as compared to just terminating an RJ45 of an Ethernet cable. So it's not all, it's not a bed of roses with fiber, but definitely there are some strong points that we should consider. Excuse me. So, like I said, you have, of course, a lot faster transmission speeds with fiber. You have much longer distance. You have noise immunity. And in terms of cost, you're looking at the per unit cost. How much am I spending per meter of fiber I have installed vis-a-vis or versus how much am I spending per meter of Cat6 or Cat7 that I've installed. On the flip side, you're looking at most likely the cost of installing Ethernet, which might be lower, as well as the ability to send power and network data on the same cable when we're using Cat6 or Cat7. So that in itself implies that we cannot just get rid of the Ethernet. Rather, we would be better off merging the two, or mixing and matching, so that you have a design that has fiber where fiber is best suited, where you get all the advantages of using fiber, and then as well Ethernet, especially in areas where you're connecting to the end user devices, where you're connecting to laptops, to desktops, to servers that have the RJ45 interfaces. Okay. Then we also want to look at the cost implications. So typically, the cost of fiber has become so low that you'll find if you get a good quality copper cable, you're likely to find that it's going to be higher. The cost, the per unit cost is going to be higher when you compare it with a fiber cable, and that is from our findings as well. You find that a 2 kilometer box of 2-core cable will cost way less than a 300. I think the rolls of Cat6 or Cat7, at least Cat6, tend to be about 305 meters. So that kind of gives you an idea of how the cost for either Cat6, Cat7, and fiber optic compare, and how you might make your decision when you're designing your network. Okay, so we reached the part that some people have probably been waiting for. We want to kind of look at what it takes to set up a simple fiber network. We wanted to do this for folks that have not dealt a lot with fiber and don't know where to start, don't know what bits and pieces to get, what they actually need to successfully have a link over fiber. So we kind of curated a few steps that I'll go through briefly, and go through the bits and pieces that you actually need to have your own fiber link. Obviously, you look at what you need. You're going to need the terminations, the endpoints. You need nodes that have got a fiber interface, and that we typically call an SFP port. So that could be a media converter, it could be a switch with an SFP port, it could be a router with an SFP port. Any of those should suffice. You want to have some fiber cable, obviously. You need some fiber cable, you need some patch codes to use for termination. You need some what we call termination boxes. These help you to join fiber and then kind of secure it and keep it placed carefully somewhere so that the splices or the joints don't get damaged. You also need what we call SFPs or transceivers, the modules that actually transmit and receive that light that we use to move our information, to transmit our information. So that's a brief of the most things that you need, the most crucial bits and pieces that you need. Then now we want to look at the actual steps. So yes, I want to set up a link, but what's the most efficient way to go about it? Or what do I do before what? So you always want to determine the network requirements for your fiber link. Things like what speed is it going to be? Do I need a 10G link, a 1G link, a 40G link? And of course, that one comes from knowing your network and your traffic requirements. You also want to know the distance. So if you can identify 2 points that you want to run fiber between, you want to know what distance between those so that you can know how much fiber you need. Then secondly, you typically would have to do a survey, that is study the environment where you want to run fiber. And that kind of informs you what kind of fiber you need, going a little back to whether it is aerial or burial, whether it is drop cable. You want to find out whether you can dig, whether you can just have some poles and run it and run aerial fiber. So that all comes from a site survey that helps you kind of study the environment and know the land, the lay of the land, if I may say. A third step would be making sure you get all the accessories that you actually need. So if you've kind of you know what distances and speeds, you kind of have a conclusion on the type of fiber that I want. Maybe I want aerial. So now I need the accessories that will go on either endpoint, the SFPs, the pigtails, the fiber patch codes that we talked about, so that I can be able to terminate each end and have data flowing from one point to the other, have connectivity. Step 4 is you'd typically run your cable or lay your cable, whether it is, depending on whether it is up or down in the ground. So you actually do the step of running the cable. And then lastly, you want to terminate and then test whether you have a link. And to test, you need some tools. Even to terminate, you need some tools. And that is what we're just going to look at in a few seconds. So once you reach step 5 and it's termination time, we want to look at what tools you need to run a fiber network or to set up a fiber network. And these are the tools that any network person, any engineer will need, so that they can either manage, they can maintain, or they can build new fiber infrastructure. We'll start with the most important, arguably the most important tool when it comes to fiber optic, and that is a splicing machine. So a splicing machine is just a device that joins two fiber cores together. Typically, we have fusion splicers, and this kind of splicers, we use. I don't think there is a widespread adoption. We typically have mechanical or fusion splicing. Mechanical tends to have a lot of losses, so most of the time, 90% of the time, people use fusion splicers, and these ones use an electric arc to melt two fiber cores or two strands of fiber or glass, if you may say, and then join them at their end faces. So typically, the process is you clean your fiber, you do what we call cleaving, and we shall look at that briefly. And cleaving is simply cutting the fiber cleanly. and cleaning off any dirt, any dust particles. And then we place them in the splicing machine, and we do what we call alignment, or typically the machine will align the cores automatically. It will burn off any impurities, and then it will fuse them using an electric discharge. So that is a splicing machine. So that's the very first thing that you need when it comes to the tool set. You do need a splicer. Another tool that we definitely need are what we call OTDRs, short for optical time domain reflectometers. So this is a tool that is when you're thinking back to Ethernet or Cat6 networks, where you have a cable tester. So this is the equivalent of that, where this is a cable tester for fiber, where you can measure the optical power coming out of a fiber optic cable, where you can measure and what we call trace faults in a fiber optic cable, trace where you're getting losses, those kinds of things. You can test the distance of a given span of fiber optic cable and be able to estimate to a high degree of accuracy how long a certain cable run is from one point to the other. So that is an OTDR, and typically you find they are smart enough that they will store most of these values that they measure, so that for a given stretch of cable you can have a bunch of parameters that you keep track of, and they are typically used to determine whether, if someone was installing or maintaining a given span of cable, whether they've done a good job by virtue of looking at the parameters at the end of the day and seeing how much power was being received after you did the work or after you spliced, how much loss were we seeing at the joints, and those kinds of parameters kind of help people be able to conform to a certain standard of work, so that you know that if you're doing my fiber works, you must always produce this level of losses, you must always produce this level of power at the end of at the other end of the link. So that is an OTDR. The other tools that we want to look at, and these we've grouped together, we've got what we call cleavers. These are little devices that cleanly cut the fiber core. The fiber core we're talking about is the small strand of glass that actually transmits information. So you have a cleaver that has got a very sharp blade that will cleanly cut the face of that fiber strand, so that it can be fused to another one the most precise way. You also have what we call strippers. These tend to remove cladding that is around the fiber core. Then we have what we call sheath cutters. These are you use these to kind of remove the outer sheath, that black PVC or plastic material that is around the cable that typically is for mechanical support. So you always use a sheath cutter to remove that sheathing, so that you can expose the tubes that have the fiber cores on the inside. So that is a bit about the tool set. Now, of course, there are so many other tools out there. Don't say we did not mention X tool or Y tool. This list kind of concentrated on the things that you need to start with, but definitely there are so many other tools out there that you can add to this list as well. Talking of cleaving, so this is kind of what it means when I say cleaving. It's basically cutting fiber and making sure it is cut cleanly enough, without any impurities, without any irregularities, if I may say. Now, kind of pivoting a little bit. So when we've seen how someone can set up a simple point-to-point link, but in our future episodes, in our future sessions, we will be looking at more complicated setups that fiber networks can offer. We are looking at what we will be looking at what we call expon networks, where you have, instead of having just a fiber network that is from one point to the other, you have a fiber network whose architecture is, you have a single point of origin and you have got multiple fibers fanning out and serving hundreds, if not thousands of clients, but from a single origin, from a single core. So that is what we would term as fiber point to multipoint. So in this family of networks, you typically have what we call X-PON networks, where you can either have G-PON or E-PON. So we'll be looking at some of the characteristics of such networks in our future sessions, where we look at why people may deploy E-PON as opposed to G-PON, and what speeds you'll tend to expect out of a G-PON network as opposed to an E-PON network, and things like that. So again, we do have fiber point-to-multipoint networks, and these ones are typically the kind of networks that deliver what we call triple play services, where you have TV, phone, and internet coming out of one connection. So you subscribe to an ISP for a connection, but it has got your TV, it can handle your phone, and also handle internet as well. So that is FTTH or X-PON networks. That is something that we'll be looking at in future sessions of Simplifi Tech Talks. Looking ahead as well, we'll want to share more topics. Now, of course, you can reach out to us and kind of give us ideas about the things that, or the technology or the application of a certain technology that you kind of are interested in, whether it is in other vendors or it is in fiber. We'll be happy to see how we can organize a session about it, or bring in someone who is an expert in that field that can give you content that is valuable. I'd like to thank you for following this session. See you next time.